Hey y'all, today is Tuesday, February 22nd, and we are starting lesson 6-1 about populations and samples on page 323. Okay, let's get started. We're actually going to skip this page, so we're moving right on to page 324. We're looking at example 1. So in example 1, it says the 2,468 registered voters in Morgantown are voting on whether to build a new stadium. Morgan and her friends really want the town to vote in favor of the new stadium. How can they determine how the voters will vote before the day of the vote? Okay, so that question is important. So I'm going to highlight that question. How can they determine how the voters will vote before the day of the vote? Okay, now let's talk some vocabulary for a minute. So Morgan and her friends could ask every single registered voter or the entire population of voters in town how they plan to vote. Now notice, I read that as every single registered voter. That is the entire population. In other words, that is the whole group. They could ask the whole group of voters how they plan to vote. Okay, but that might be a really time-consuming process. It says, however, surveying 2,468 people takes a long time. Morgan and her friends may not be able to survey the entire population of voters. So instead, they might survey a sample. Morgan and her friends could ask a subset or a sample of the registered voters in town how they plan to vote. So if all of the people up above, all of those like kind of greenish colored people are everyone, all of the registered voters, they're the whole group, the whole population, well, Morgan and her friends might ask just these people in a brighter green how they plan to vote. And so that's a subset. You're only asking a few people. So a subset or a sample is only part of the whole group. So they're going to ask just a few people of the whole group how they plan to vote. So surveying a sample of voters does not take as long and is more reasonable to do. Morgan and her friends would be able to ask 100 or 200 people. Okay? So let's try it down at the bottom. Miguel thinks the science teachers in his school give more homework than the math teachers. He is researching the number of hours middle school students in his school spend doing math and science homework each night. Okay, let's look at these little boxes over here. The blank includes all of the students in Miguel's middle school. Well, keywords, all of the students. Which word, population or sample, represents the whole group? All of them, every single person. Well, that's the population. So the population includes all of the students in Miguel's middle school. A possible blank is some students from each of the grades in the middle school. Keywords, some students, just a few of them in each of the grades. That right there is our sample. So a possible sample includes some students from each of the grades in the middle school. Okay, let's look at this convince me. Why is it more efficient to study a sample rather than an entire population? Okay, well, we kind of touched on it earlier. A population can be really, really large. So populations can be really big. And because they're so big, it would take a long time to survey everyone. Okay, Now, in some cases, it could also be too expensive to survey everyone. So when we think about like a national vote, when we go vote for president, if we were to survey every registered voter in the whole United States, that would take a really, really long time, and it would also be very expensive for someone to do so. So sometimes money can also be a factor. Okay, let's move on to the next page, page 325, example 2. So Morgan decides to survey a sample of the town's voting population. How can she know that the survey results from the sample of voters represent the position of the entire town's population? Okay, so that question is important. How can she know that the survey results from the sample represent the position of the entire town's population? And to answer that, we're going to look at these definitions here. So the first one, a representative sample. A representative sample accurately reflects the characteristics of the entire population. So it represents how the entire population feels or how the entire population would act. Okay? Now, in a random sample, each member of the population has an equal chance of being included. A random sample tends to be a representative sample. A random sample tends to be a representative sample. That right there is really, really important. So if she surveys a random sample of people, then that should reflect how the entire population will act. So Morgan can survey a random sample or randomly selected group of voters to make sure her results represent the position of the entire town. Okay, now let's try it. A produce manager is deciding whether there is customer demand for expanding the organic food section of her store. How could she obtain the information she needs? Okay, so this is our question here. How could she obtain the information that she needs? Well, we know that she cannot survey every single customer. That would just be too large of a group. It could take too long, right? So she needs to survey just a sample. Now, she can't just pick the people that are shopping in the organic section because they're going to have a biased opinion, right? They're going to want a bigger section because they're already shopping in what is the current organic section. So she could survey randomly selected shoppers, right? So that's what we're going to say. She could survey randomly selected shoppers to form a representative sample. Now, why is it important that the shoppers be randomly selected? Well, randomly selected samples will form a representative sample. Okay, so that randomly selected is very important there. Okay, let's look at example 3. So it says, how can Morgan generate a random sample of the town's voting population? Well, it says Morgan can do the following steps. Step 1, define the population. Step 2, choose the sample size. Okay, and then there's this little note. The larger the sample, the more confident Morgan can be that the results represent the position of the population. So we don't need the sample to be too large. Remember when we were talking about the number of voters in the population? I think it was like 2,468. I think that was right. Let me go back and double check. Yes, 2,468. So if she surveys 2,000 people, that's still going to take a lot of time. So that would be too large of a sample, right? But surveying 100 people or 200 people would be reasonable, and it would still, as long as it's randomly selected, be a good enough size that she could feel confident that her results will accurately reflect the population's intentions. Okay? So the larger the sample, the more confident you can be in your results. Now, step 3, make or acquire a list of all members of the population. Step 4, you could assign a number to each member of the population. And then step 5, generate a list of random numbers to select sample members. Okay, so steps 4 and 5, 3, 4, and 5, really, that's how Morgan is ensuring that she is getting a random sample so that it will be representative. Okay, let's look at this, try it. Ravi is running against 2 other candidates for school council president. All of the 750 students in Ravi's school will vote for student council president. How can Ravi generate a representative sample that will help him determine whether he will win the election? Okay, well, he cannot survey all 750 people. That would take too long. It would be too difficult. So he could assign each student a number. Okay, so he would have numbers 1 through 750, and then he could randomly select numbers until he reaches a desired sample size. So how could he randomly select those numbers? Well, this day and age, there are random number generators online that you could use. So he could say, okay, I'm going to survey 75 people, that's 10%, and I'm going to use a random number generator to create a list of 75 random numbers. So that would be how I would do it if I were Ravi. Okay? Moving on to the next page, page 326, example 4. So Morgan and Maddie will each generate a random sample of the 138 students in 7th grade at their school. They each write the numbers from 1 to 138 on small pieces of paper and put them in different hats. Then they draw 20 numbers randomly from their hats. What do you notice about the 2 random samples taken from the same population? What does this tell you about their sampling technique? Okay, so these are the questions that we're asking. What do you notice about the 2 random samples taken from the same population? And then, what does this tell you about the sampling technique? Okay, so let's look at Morgan's sample. So we're looking at this right here. Okay, so we've got 20 different numbers. So 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4 times 5, 20. 20 different numbers. So there were 20 people surveyed in Morgan's sample. And Maddie's sample, let's compare that one. How many people are in Maddie's sample? Well, this table's the same size. 1, 2, 3, 4. And then 1, 2, 3, 4, 5. So 20 people still. So there are 20 members in each sample. Okay? Now, it highlighted the numbers that are in common for us. We see that 38 was selected in both samples, as was 106. Okay, so the only numbers in common to both samples are 38 and 106. Now, the numbers are distributed differently in each sample, and that's what these graphs show us here. So in Morgan's sample, there are 2 people that have numbers less than 20. There are 3 people with numbers between 21 and 40. There are 4 people with 41 to 60, and so on. Okay, so I see in Maddie's sample, numbers 21 through 40 appeared several more times. There are 5 people with a number between 21 and 40. Okay, however, there's only 2 people with a number between 41 and 60, whereas in Morgan's sample, there were 4 in that category. So it's distributed differently. Okay, so here's what we would note. The sampling method produces random samples that have mostly different members, but that are each likely to be a representative sample of the population. Well, how do I know that they're each likely to be a representative sample? What do they need to be? What do samples need to be in order to be representative? They need to be random, and both of those were random samples. Okay, so let's look at the triad. So the table at the right shows the random sample that Jeremy generated from the sample population, or from the same population, that Jeremy generated from the same population as Morgan's and Maddie's samples. Compare Jeremy's sample to Morgan's and Maddie's. Okay, so when I look at Jeremy's sample, I see this sample right here, and there are 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4 times 5, 20. So there are 20 members in the sample. So I'm going to say that. That's the first thing I'm going to say. 20 members or 20 people in the sample. Okay. What else? Let's see if there are any common numbers. So 38 and 106. Are any of those numbers in common? Because that would be interesting if all 3 had those numbers. But they don't. 38 and 106 do not appear in Jeremy's sample. But do any other numbers appear in other samples? So if I look at Morgan's sample, so 55, 114, 97, 38, 87, I don't see any of those. 49, 106, 50, not seeing any of those. 91, 96, don't see any of those. 28, 18, 83, I don't see those. 36, 15, 79, 36, 15, 79. Oh, I see a 36. 36 right there. So there's a 36 in both Morgan's sample and Jeremy's sample. Okay, but notice there was not a 36 in Maddie's sample. So just Jeremy and Morgan have 36 in common. Okay, now let's see. So we did, I've got 130, 109, and 46. 130, 109, and 46. I don't see any of those. The last one is 93. I don't see any of those. Okay, so now let's compare to Maddie's sample. So 38, 25, 100, 38, 25, 100, I don't see that. 135 and 67, 135 and 67, I do not see. 106, 35, and 119, 106, 35, and 119 does not appear. 103, 7, and 21, 103, 7, and 21 does not appear. 94, 27, and 13. So 94, 27, and 13, I don't see that either. 74, 102, 126. So 74, 102, 126, I do see right there. So there's a 126 in both Maddie's sample and in Jeremy's sample. Okay. Let's see, I've got 3 more numbers to check, 51, 72, and 54. So 51, 72, and 54, I do not see. Okay, so I think those are the only 2 numbers that repeat. Okay, so let's talk about that. So we know that number 126 is also in Maddie's sample. Okay, we also know that number, 36 is also in Morgan's sample. Okay, that's what we know about those. But do any numbers appear in all three samples? No. No numbers appear in all three samples. No numbers appear in all three samples. So, is Jeremy's sample likely to be representative of the population? I would say yes. Why would Jeremy's sample be representative of the population? It's a random sample. So, I would make a note. Jeremy's sample is random or randomly selected. That's what I'm going to write. And therefore, likely to be representative of the population. And I don't have room to write that, but Jeremy's sample is randomly selected and likely to be representative of the population. Okay, so all three samples are randomly selected and likely to be representative of the population. Okay, let's move on to the next page. So let's read through this key concept here. A population, key word, is an entire group of objects, people, animals, plants, from which data can be collected. So key phrase, population is the entire group. It's the whole group. Okay? A sample is a subset of the population. It's only part of the population. It's not the whole group. When you ask a statistical question about a population, it is often more efficient to gather data from a sample of the population. So, more efficient to gather data from a sample of the population. More efficient means you're going to save time and you're probably going to save money as well. Okay? Now, a representative sample of a population has the same characteristics as the whole population. Generating a random sample or making a random sample is one reliable way to produce a representative sample of a population. That right there is really, really important. So I'm going to put a star next to that. You can generate multiple random samples that are different, but that are each representative of the population. Okay, now that we've gone through that, let's look at the do you know how. So we're going to start with number 4. A health club manager wants to determine whether the members would prefer a new sauna or a new steam room. The club surveys 50 of its 600 members. What is the population of this study? So what is the population? Remember, population refers to the whole group. And we know that there are 600 members. That's the whole group, right? They survey 50, but there are 600 people that are members of this health club. So what is the population? All 600 members. Okay, let's move on to number 5. A journalism teacher wants to determine whether his students would prefer to attend a national writing convention or tour of a local newspaper press. The journalism teacher has a total of 120 students in 4 different classes. What would be a representative sample in this situation? Okay, so the sample is not all 120 students, right? And the sample can't just be the students in one of the 4 classes. We need to represent all 4 different classes in our sample. So what the teacher could do is put names of all 120 students in a hat and randomly select names to create a random sample. That would work. The teacher could assign each student a number and use a random number generator to create a sample. There are different ways that he can do it. But as long as he has students from each class represented in his sample, then that will be a randomly selected sample. And if all 120 students have an equal chance of being selected, then that is also a randomly selected sample. So what I'm going to write here just for my notes, for my answer key, I'm going to say the teacher could put all the names in a hat and randomly select names to create a random sample. Okay, let's move on to number 6. Garrett wants to find out which restaurant people think serves the best beef brisket in town. So part A, what is the population from which Garrett should find a sample? Well, so what is the population? And he's trying to find which restaurant serves the best beef brisket in town. So wouldn't the population be the whole group? Wouldn't it be every resident in town? That's what I think. So I think the population is all residents of the town. And remember, residents means people that live in. So everyone that lives in the town is part of the population. Okay, so B, what might be a sample that is not representative of the population? Key word there, not, right? So something that's not representative, he could survey the customers at one of the restaurants that serves beef brisket. So why would that be a non-representative sample? Well, if the customers are at a restaurant that serves beef brisket, they're likely to think that that restaurant has the best beef brisket in town, right? So it would create a biased sample. So the customers at one of the restaurants that serves beef brisket would not be a representative sample. Okay? That is the end of our notes for today. Your homework will be posted in Google Classroom. Bye, y'all.